Alright, so in 3.4, there's the one-to-one property and the inverse properties are going to become very helpful to you when solving equations. The one-to-one properties, you've practiced them on 3.1 and 3.2. So remember, if you have a base to a power and that is equal to the same base to a power, that means that the powers, you can set them equal to each other, right? Same thing with logarithms. If you have two logarithms in which the bases are the same, then you can set whatever you're taking the logarithm of equal to each other. Cool? Those are known as a one-to-one property. Okay? For those of you watching the video and you don't remember what this means, the three dots means therefore. Okay? Then you have something known as the inverse properties. The inverse properties is the one that I talked about earlier in class here. If you have the logarithm of base power, the logarithm of base A of A cancels each other out, being just 1, right? So 1 times x is just x. Well, if that's true with logarithms, then it should also be true with exponentials, because logarithms and exponentials are inverses of each other. So what I'm trying to say here is, for example, if you have a base of A and you raise it to the logarithm of the same base, they will cancel each other out, leaving you just with whatever you are taking the logarithm of. Okay? Are these properties essential for you to know to solve equations? No, but it can make solving equations a lot faster. The other strategy that I don't want to write down, but you can kind of take a note of, is that to solve exponential equations, you can turn them into logarithms, and to solve logarithmic equations, you can turn them into exponentials. Cool? That's really the strategies or using these properties that you have present here. Alright, we're just going to go ahead and just dive into problems. We'll start with basic problems and we'll move on the level of difficulty. Okay? First example. E to the x power equals to 72. Any thoughts? How did you know that? Did you turn it into just a log? Or did you use one of the properties? Okay, two strategies here. I'm going to use the inverse property just to show you how the inverse property works. I'm going to take the natural log of both sides. Okay? On the left-hand side, this is a property. This is the inverse property because natural log has what base? So when you have the bases matching the base, you're just left with whatever you're taking the logarithm of, which in this case is the power, which is x equals natural log 72, and you would be done. That would be using the properties. In my opinion, there was a faster way of doing this, which was turning something that's exponential into logarithm. Log of what? What base? E of equals 2x, and you need to simplify that by ln 72 equals 2x. So as you can see, both methods arrive to the same answer. Whichever you prefer, I honestly don't have any preference. Okay? Questions? This one used the inverse property. This one just used turning an exponential into a logarithm. Cool? Alright, next one. Example number 2. 3 times 2 to the x power equals to 72. No, let's make it, yeah, why not, 72 again, why not? Okay. Any thoughts? Definitely, your algebra skills should still come into play here. So I'm going to divide by 3. Okay, so 2 to the x is equal to, what's 72 divided by 3? 24. You guys agree? Okay. Now what? So turn into a log? Okay, sure. Log. What type of base? 2 x. Is that going to simplify any further? No, right? 2 to there's no power where there is a power, but there is no integer power that you can take 2 to get 24. Agreed? So I wouldn't expect you to give me an answer or anything simplified further than this. If I give you a calculator for this, which I more likely would not give you a calculator for a problem this easy, you can just plug it into the calculator and you will give me an approximation to 3 decimals. Okay? But that's what I will call it. Now, just to practice, how would you use the properties above that we have to solve this problem? Can I use logs? Yes, sir.
Like log 24 over log 2.
Oh, that's like change of base formula. I see what you're saying.
Oh,
Yeah, no, I mean like starting here, instead of turning it into a log, can I use the inverse properties? What's the base of this exponent? So if I take the base of the same logarithm, so could I just say log base 2 of 2 to the x? But what I do to one side, you have to do to the other. So the other side would be what? Log base 2 of 24. What's going to happen with the log base 2 of 2? X equals log base 2 of 24. And I get the exact same thing. Personally, personally, it's just a personal preference. I like to use the properties a lot. You don't have to. Again, in my opinion, for this problem, it would have been a lot faster doing this, right? All right, but questions. Do you guys see how those inverse properties can actually be somewhat helpful? Definitely when the problems get a little bit more complicated. Okay? All right, so moving on. Example number 3. I feel like you guys are getting it, so I'm just going to skip a few. So let's try something more difficult. So 2 times 3 to the 2x minus 5 power minus 4 equals 211. So 2 times 3 to the 2x minus 5 power minus 4 equals 211. Any thoughts? At 4, yeah, but definitely. So we have 2 times 3 to the x minus 5 power equals 15, right? Then what? Divide by 2. 3 to the 2x minus 5 equals, I want you to leave things as fractions. Please don't turn them into decimals. So 15 over 2, right? Now what? Okay, you cannot, wait, hold on, did you say divide? Yeah. Use the inverse properties. How can I use the inverse property for this one? What's the base here? So then, log base 3 of what?
Can I go again and speak for like 2 seconds?
Yeah. So log base 3 of 3 to the 2x minus 5. And what you do to one side, you have to do to the other. Log base 3 of 15 over 2. Agreed? Okay, what's going to happen on the left-hand side? This right here will cancel each other out, leaving you with 2x minus 5 equals to logarithm base 3 of 15 over 2. Agreed? Now what? I still need to solve for x. I'm going to have to add 5 and divide by 2. Can I do it all at once? Yes, you can. I was just asking you, like, is anyone going to get lost if I do it all at once? Okay. Alright. Log base 3. And look at the way I'm going to write this. I put parentheses in there just to make sure that you don't get confused that the plus 5 is within the log, which is not, right? And then divided by 2, right? Is that okay if instead of dividing by 2, I can put a 1/2 there? And then this would be over 2, right? You guys with me? So then you have 1/2 log base 3 of 15 halves plus 5 halves, right? Okay, because you are pre-AP, I would expect you to take this one step further. Any thoughts? Power rule. How can I use the power rule? This 1/2 becomes a power of 1/2, but you need to know that a power of 1/2 is a what? Square root. So x equals to the logarithm base 3 of the square root of 15/2 plus 5/2. Would the root of 15/2 get any simpler? No. We're done. For the purposes of you trying, I understand what you're saying here, but for the purposes of me trying to make sure that you understand the properties, I'm going to want you to apply it. Well, this wouldn't be on the quiz, like this specifically. This will be on the test. Okay? On the quiz, you will have the properties, but it won't be in the form of an equation. It will be like, can you use the properties to expand? Can you use the properties to condense? Okay? What's up?
So, for this problem, we still didn't have to use the properties, though.
I know.
So, like,
I'm just trying to get you to practice them. I agree. You could have, at this point right here, could you have just turned into a logarithm? Right here, just from the beginning of the problem, like at this point. Could you just have said log base 3 of 15/2 equals to 2x minus 5? Yes. I get your point. Like, why am I showing you something that takes longer? Because there will be problems that you can't just turn them that easily into a logarithm. That's all. Okay, so I'm just trying to make sure that with easy problems I can show you how it works, so that when you do arrive to a problem where turning things into a logarithm won't be that simple, you can apply the properties. Cool? But I totally agree. Again, at this point, right here, I would have just turned it into a log. Right? That would have been a lot faster. Cool? Alright, any questions with exponentials? Are we ready to move on to logarithms? Okay, here we go. Actually, there's one problem that I forgot I want to deal with exponentials. Okay, so here we go. Check this out. What if you have the following? Okay, so we're in example number 4, I believe. E to the 2x minus 3 times e to the x plus 2 equals to 0. Okay? We have a problem here that's a little different than all the other examples that we've tried. Had only had one variable on the exponents, right? That's it. But this time you have variable on this exponent, and then you also have a variable on this exponent, right? So we have more things to take care of. Okay? Any thoughts of how we can go about this? Like take the natural log of everything?
Yeah.
Okay, so you're saying take the natural log of this, take the natural log of that, take the natural log of that, and then take the natural log of that. But then, can we take the natural log of 0? No, right? Like, can you take the natural log of a 0? No. So I like your idea. So we could have taken the natural log of everything, but the fact that we can't do the 0, that messes things up. Okay? Now, your idea was to subtract the 2?
Yeah.
Okay, so if I subtract the 2, then what would you do after that?
Yeah, what can you do L in the negative?
No, you get I, right? And you get to do it I.
Okay. So you're thinking like now I'm going to have imaginary things, imaginary numbers. Okay? What do you think, Drew?
Can we factor this?
What do you mean factor this?
Like 2, so it would be EX plus 2EX, or minus 2EX.
Okay, so you're telling me that this would be EX what? Minus 2.
Oh wait, that's
Is he right?
Yeah.
What's EX times EX?
oh wait, no, that's EX.
Squared.
Oh,
EX times EX is EX squared. What's a power to a power? You multiply. You're totally correct, Ruth. E to the x times e to the x gives you e to the 2x. e to the x times negative 1 gives you negative ex. Negative 2 times ex gives you another negative 2, so together it makes negative 3. And then negative 2 times negative 1 gives you 2. This right here is a quadratic. Okay? So, now that you know it's a quadratic, you know that all quadratics must be set equal to 0. Therefore, that's the reason why earlier you asked me that you wanted to bring that 2 over and then bring the take natural log. I see why you would think that, but now that you know a quadratic, you got to remember from algebra 2 that you cannot solve a quadratic unless it's equal to 0. So good thought there, though. I totally get where you were going with that, okay? But do you guys now comprehend why I cannot do that? Okay, because it's a quadratic. So now that you have this, what do? E to the x equals to 2, e to the x equals to 1, right? Therefore, what is x equal to on this side? ln 2. And what is x equal to this one? ln of 1. This I would accept. This I will not. I will mark it wrong. What is natural log of 1? 0. That's one of the ones you have to have memorized. And you know this. It just takes you a little time to process, because you know that anything to the 0 power is 1. Therefore, the natural log or any log of 1 would be 0, because they're inverses of each other. Okay? Questions. Quadratics will show for sure on the test. Okay? So you want to put a star by this question. Alright, finally, we can go ahead and move on to logarithms. Example number 5. Alright, let's start with something very simple. ln 3. Very easy. Any thoughts? Not quite. You have the right idea, but not.
Oh wait, e to the third power is that.
E to the third equals x. For those of you that got lost, ln is the same thing as having log base e of x equals to 3. And remember that to turn a log into an exponential, you take the base to this power, and that's equal to whatever you have there. Cool? Could I have used the properties instead of turning into an exponential? How could you use the properties for this one? What was the base of this logarithm? So I'm going to take e and raise it to that power. And what I do to one side, I do to the other. E to the third. E and natural log are going to do what? X equals e to the third. So do you guys see how the property is still helpful, still useful if you wanted to use it? Okay? Alright, moving on. Example 6. 5 plus 2 natural log x equals to 4. Alright, thoughts? Subtract what? 5. So then 2 ln equals negative 1. Right? Then what? ln x equals negative 1/2. Right? Lastly, I wouldn't use the properties here. I would just go ahead and turn it into a exponential, right? That would be a lot faster. So what would it be equal to? X equals to e to the negative 1/2. You'll be done. What's that? You could rewrite that if you wanted to as x equals 1 over e squared. Cool? Any negative power brings it down. Wait a second. It's negative 1/2, so it's what? Square root, I'm sorry. Not 2. Get rid of that 2. Square root of e. Sorry, my mistake. Alright, because it's still... The 1/2 tells you that it's a root, right? And the negative tells you that it would be on the denominator. Cool? Alright, we have a couple more examples and we're done. Actually, you just have one more. Natural log of x minus 2 plus natural log of 2x minus 3 equals to 2 ln, or natural log of x. I'm sorry. So this is our last problem for the day, and we're done. Alright, so this is kind of like the same situation what we had earlier with that quadratic, sort of, right? We have variables in multiple natural logarithms here, right? Any thoughts? My hint to you is there was a purpose or there was a reason for 3.3 to exist before 3.4. You can't factor ln because ln it's you can't separate the natural logs. You have to condense. Good. By using the properties. What happens when you have two natural logs that are being added? How can you convince them? You have to convince them to condense. Alright, so how can you condense them? You multiply what by what? This by that. So this becomes natural log of that times that. So x minus 2 times 2x minus 3 equals to, I'm going to take one more step here. What can you do with that 2? Power rule. Agreed? Okay. What do you guys think I could do next here? You can do the inverse property by doing what? E to that power and e to that power. Agreed? What's going to happen with e and ln? Cancels away. So then you'll have x minus 2 times 2x minus 3 equals what? X squared. Simplify this out. That's going to give you 2x squared minus 5x. No, 5, that's 4, that's 7, right? Minus 7x plus 6 equals to x squared. Bring over the x squared because you're dealing with a quadratic. X squared minus 7x plus 6 equals to 0. Agreed? We good? X, negative 6, negative 1. Therefore, x is equal to what? 1 and 6. Alright, there is one thing I forgot to mention, and I gotta make sure that I mention it before I forget. One of the most important things you need to know about logarithms is that you cannot take the logarithm of a negative number. So you always need to check your answers. Here's what I mean. 6. If you go back to the beginning problem, all the way here, if you plug in 6, 6 minus 2 is 4, so no problem there, right? 6 times 2 is 12, minus 3 is 9, so no problem there, and then 6, we're good, right? So this is definitely an answer. 1. 1 minus 2 is, can you take the natural log of negative 1? Nope, which means that this right here will not be a solution. It is known as an extraneous solution. So make sure that you check your answers when you are dealing with logarithmic equations. Other than that, that is all I have for you today. The homework is on the calendar. Quiz on Friday. Cool? Quiz will not be including this material from today.